Allora, siamo pronti per dare spazio ai prossimi due speaker, Marco De Benedictis e Francesco Beltramini, entrambi all'interno di Control Plane, che ci parleranno un pochino di come integrare dei tool open source per il contesto di security all'interno di una supply chain. Spero di aver riassunto molto bene in due parole quello che dovevate dire. Vi lascio il palco, in bocca al lupo, ci vediamo più tardi.
Grazie.
Mi passo in mezzo.
Check, check, mi sentite? Perfetto. Grazie a tutti, appunto Marco e Francesco di Control Plane, ci introduciamo tra pochissimo. Grazie a tutti gli organizzatori di KCD Italy, sta riuscendo molto bene mi sembra, quindi grazie. E la talk in inglese, non perché vogliamo fare i fighi, ma perché noi siamo un'azienda inglese, quindi parliamo di questa roba sempre in inglese. So, welcome and thank you for coming. This is Untrusted Execution, Attacking the Cloud Native Supply Chain. Marco.
Yeah, hello everybody. My name is Marco. I'm a security engineer at Control Plane. I've been there for 1 year now, and I'm mostly focusing on threat modeling and security reviews for our customer environments, workload with Kubernetes and cloud native in general. And before that, I was employed as a security researcher in Politecnico di Torino, that I'm sure some of you know. And yeah, I did a PhD there and then moved to the industry. And yeah, Francesco.
Thank you, Marco. I'm Francesco. I'm the security engineering manager for Control Plane. So I lead the security consultants. I studied in Verona with that man over there, Diego, and others. Then I moved to the UK in 2010, working for the European government. And after that, I worked for a large satellite mobile provider, leading the security engineering team. And after that, I landed in Control Plane because I didn't want to see a network cable or a data center anymore in my life. Control Plane is a cloud-native security consultancy headquartered in London, established in 2017. We are security specialists in cloud, Kubernetes, and containers. We are well-versed working for regulated industries, governments, financial institutions, and we are just over 50 people across UK, Europe, Asia Pacific, and North America. We wrote the book on Kubernetes security, published by O'Reilly. That's the author, our CEO, Andy Martin. You can actually download the first half for free of the book if you scan the QR code over there. But if you don't have the time to scan it, come and see us. We have a few digital copies here. Right, again, real quick, what are the core competencies of our firm? We believe in deeply threat modeling everything. That includes Kubernetes and container orchestration in general, and cloud security. We are large advocates of zero trust architectures, secure by design, secure by default. We consult on DevSecOps infrastructure and application delivery. We fill the gap between security operation centers and cloud native, so that observability gap. We also look at hardened SDLC and supply chain building automation, and we do pen test of all that. Real quick, a few badges. We are co-chair for the tag security. Mark also has a big presence in that team for the Linux Foundation. We are also part of the CNCF Financial Services User Group. For them, we built and open sourced a Kubernetes threat model. You can access it now if you want, and associated attack trees. So pretty interesting. We are also silver members of the FINOS, the FinTech Open Source Foundation, and our CEO, Andy Martin, is also the CISO pro bono for Open UK. Right, enough. What are we going to talk about today? After the excellent talk this morning from Paolo and Andrea on supply chain security, this is a complementary view, very much hinged on threat modeling. So selecting controls, selecting countermeasures to harden your supply chains based on a formal threat model. You do end-to-end of these very software supply chains for your organization. Right, so we'll talk about the problem, threat modeling as a way to fix the or to answer the questions, and then how to actually do the hands-on hardening. That's got to be Marco's piece. Right, so what are the existential questions that security professionals like us ask ourselves when dealing with supply chain security? Where the code comes from? Where does it go? What do we actually ingest? And how can it go wrong? And what are we going to actually do about it? Right, let's try to define the supply chain problem itself. And to do so, we have to define what is a supply chain. Real quick, because we heard again from Paolo and Andrea what a supply chain is in the morning. In general, is anything that we depend upon. And for example, in the military sector, they need to know exactly all the hardware and software, where it comes from, and who built them to protect against very sophisticated nation-state attacks. But in the pharmaceutical sector, when human safety is involved and directly impacted by their supply chain, they need to know with the provenance of all their ingredients they use to, do all the drugs. Right, so in our space, let's look at a small example here. We have a Kubernetes cluster running workloads. We have our pipeline on the right-hand side in pink. And we have all our upstream producers, so things we depend upon. And then we have our downstream customers down there. And in this example, we have an attacker, Captain Hashjack, with 2 vantage points. One is the public internet. Many attackers do. And the second vantage point is, as they say in the morning, one of our suppliers. Because what happened is that they managed to compromise one of our suppliers, and in particular one that built and give us a library critical for our business, right? And what they can do, for example, is inject some malicious payload in it. And in this example, the payload itself is going to be a reverse shell. Right, so what happens when the pipeline kicks in? The malicious dependency is pulled, it's baked into our source code, and packed in the image ready to be executed on our runtime. And after that, the payload executes, and in this specific example, a reverse shell will establish an egress outbound connection, not as easy to detect as an ingress connection, to the other vantage point that the attacker controls. And through this reverse shell, they can actually land on our compromised payload, workload, and they can execute commands with the permissions of the workload. That's one of the ways. One of the other ways is to infect our source code directly, or to infect our build infrastructure, or to target directly our runtime that we use to serve our downstream customers. Right, so that sounds quite bad. But if there is something that computer security always teaches us, it can always get worse. And reason being, supply chains are very large, are big, are complex. They are adaptable and flexible, but that introduce non-deterministic behavior, visibility gap, and also sometimes they're also ephemeral. So how do you deal with all that? Well, we either don't use them, too late. We use them and we don't care about security, really. Or we try to secure everything, but you know better, it's an impossible task. So our approach is to, again, threat model supply chains end-to-end, from upstream producers all the way to downstream customers. And at the same time, we work with the community to develop and adopt standards, best practices, reference architectures, and we keep improving those. Right, let's talk about threat modeling. For those of you who don't know, threat modeling is an approach that should bring everyone at the same table, managers, technical people, devs, SREs, platform engineering teams, everybody. And it focuses on data and data flows. And the final result is ultimately to identify and address security risk in your system. It's an iterative process, 4 stages. It works really well when you do it, when you design your system. In step 1, we ask ourselves, what are we actually building? Step 2, we ask ourselves, what's the worst that could happen? In step 3, we ask ourselves, how can we actually reduce the risk of bad things happening? And this is where we select security controls and tools to de-risk those threats. And in step 4, we ask ourselves, did we actually do a good job? So we measure the threat modeling exercise itself. For the sake of this presentation, we focus on step 2 and 3. What are the threat modeling outputs? Threats, so statements back to risk, business risk. We derive attack paths that are the individual steps that bad guys need to perform to exploit a potential threat. Attack trees, visual representations of the attack paths, and then security controls, preventative and detective security controls, and countermeasures. And we apply those end-to-end to our supply chain. And why do we want to do it? Because what controls do? They break attack chains. So you either make an attack step really difficult to perform beyond the attacker capabilities, or you make it completely impossible. This is an example of an attack tree. We have other to show you, even real-world ones, quite complex. We open-sourced one, as I said, for the financial services user group. You can find on GitHub. Right. For the rest of the presentation, this is going to be our reference architecture. It's an end-to-end supply chain from third parties we consume software from, our dev environment, our build environment, our runtime, ready to serve our hungry downstream customers there that want to buy stuff from our e-commerce. And within this, again, high level, but within the build and test stage, we have fetch, where we source all the code from the outside world and internal repositories. We have the build stage, test, publish to an artifact repo, to then ingest into our runtime and serve, again, the hungry customers. When I talk about threats identified in a threat model exercise, those are threats to what? Fundamentally, those are threats to security properties of our supply chains. And if you have this sort of architecture, high-level architecture of your supply chain, it's easy to see where the boundaries are and how you should scope your threat model exercise. So threats to the source integrity, threats to the build integrity, and threats to the runtime integrity. As an example, we have a few here, again, based on our findings in assessing real-world supply chains. In terms of build, there could be a compromise of the build of the platform or the processes associated. There could be somebody tampering with your artifacts as you publish them before ingesting them into runtime. Or there could be a way to bypass your CD pipeline or bypass your admission control at runtime. Those are all the threats we target, and to de-risk those threats, we use security controls. And Marco, from now to the rest of the presentation, will talk about those controls and tools.
Thank you very much. So yeah, we've talked right now about what are the inherent threats to software supply chains, but it's time to talk about what are the actual controls that we can enforce. And just by thinking about what we've been discussing this morning, there has been a lot of talk around community, right? So the way we've decided to go with this is by talking about the open source community efforts around software supply chains, and yeah, how can you actually implement end-to-end integrity monitoring and preserve a controlled environment in a software supply chain. So here you will find just some pointers. As Francesco was mentioning before, we are deeply involved with the CNCF. There are several initiatives throughout the CNCF and OpenSSF, which was also mentioned this morning. And here you find some of the links and how those tie together. So on the left-hand side, you see a couple of initiatives that come from the tag security working group within the CNCF, which focuses on security, of course, where a software supply chain best practices white paper has been developed quite some time ago. And it, let's say, talks about some of the high-level overarching security principles that we should be adhering to in our software supply chain. Starting from there, a reference architecture for a software supply chain has been developed, named Secure Software Factory, and we will talk about that in depth in the following slides. On the right-hand side of this slide, you see an initiative by the OpenSSF, which is actually being mentioned this morning, quite in depth, called SALSA. And this is also another initiative talking about several guidelines that help us define how our software supply chains should be secured. And it's very convenient because it not only lets you perform a kind of assessment of a pipeline, because you can define levels of, let's say, compliance to a software supply chain, but they also have worked a lot with defining standards, formats for attestation and stuff like that. But yeah, before going further, for those of you who do not work in that much in security, it might be useful to go through a little bit of definitions. We'll talk about provenance in this presentation, and provenance means any kind of claim that some subject produced a software artifact taking as an input a set of artifacts or dependencies, whatever. And yeah, this was following a kind of recipe, okay? This is called provenance. And when we take this information and we cryptographically sign it, then we attest this information. We can have an attestation of that. Of course, as part of our software supply chains, there is a lot of verification involved, and we talked about that. And verification, yeah, it's kind of straightforward, means that we need to have some cryptographic way of validating that signatures. Yeah, the secure software factory. This comes as a reference architecture, as I said, and this reference architecture builds on several principles, high-level principles from the white paper. These are defense in depth, signing and verification, artifact metadata analysis, and automation. And the way Secure Software Factory has been developed is by looking at these principles and trying to apply them to these 5 functional areas of the software supply chains, which are source code, dependencies, build pipelines, artifacts, and deployments. By looking at that, within the Secure Software Factory, several controls are proposed, and they all look at provenance verification, trustworthiness, and dependency analysis. And they apply these concepts, which might look like high-level concepts, to specific phases of a software supply chain, okay? So we are talking about pre-build, like dependency ingestion, what happens before we actually build our artifact, the build phase, which is kind of, yeah, straightforward, and the post-build phase, which is when we actually want to deploy our artifact. Yeah, let's start with the first one. We are talking about pre-build integrity, and these are some of the controls that Secure Software Factory tries to implement and, to define. We start from the source code, right? So when we talk about source code, we are talking about managing our repositories, and we are talking about signing source code, for example, using GPG-signed commits. That's a starting point, might look like security hygiene, but that's kind of an important point to start having some form of attestation or be able to verify the actual code that's been built in a code base, right? That's just a start. And as part of the pre-build phase, we are also pretty much interested in everything that has to do with third-party dependencies. And this was talked about in this morning. So we are talking about verifying third-party dependencies, performing some form of risk analysis for them. And in order to do that, there is a big issue that I'm going to talk about in a moment, which is where do we actually gather all the data for all of these third-party dependencies, how we can trust this data, and yeah, can we find enough data, first of all, and is it normalized in some way? Can we actually automate any form of analysis on top of that? Then, yeah, we, as part of pre-build phase, we are interested in scanning our code. And yeah, this is where like any kind of code quality, code security, code review comes into place. And finally, and this is one of the bigger, let's say, the most important items, in my opinion, we have to find a way to keeping track, let's say, of each step within our pipeline, being able to sign these steps and tracking all the metadata that comes with our pipeline so that then we can push this information somewhere and somebody can verify this. I'm going to talk about several acronyms here. So yeah, one of them was also, a couple of them were actually mentioned this morning. We already talked about SBOMs, which are the recipes of how software is built, called software bills of materials. We also have VEX. This is, let's say, another initiative which is actually concerned with an important topic, which is how do we actually assess the impact of a vulnerability in our application. So let's say that we have an actually vulnerable dependency, right? But how do the maintainers tell us whether that dependency is impacting the final product or not? So that's when VEX comes into place. There have been like, there is a format which has come out of this initiative, where you can actually find like a kind of document, XML-like document, where you can put this information as a maintainer of a product, of a project. Salsa has already been mentioned, so yeah, I won't spend much time on that. Helps define some guidelines for how to secure build pipelines and formats along that, such as the in-toto attestation format. So this is the same pipeline that we were talking about previously. You see that we are starting to add some components to it. So this is kind of security augmented pipeline, where we now are going to focus to the red boxes, where we are talking about, first of all, secure software ingestion, and that's where we want to gather SBOMs, VEX documents if there are, SALS attestations. We want to take all of this information and be able to analyze that, perform our vulnerability scans on top of that, so that we can actually reason whether this complies or not with our company policies. Of course, we want also to scan our code. I mentioned that earlier, not going to talk in detail about software composition analysis, SAST, DAST, but of course we need to do that as well. But we have a problem here that I briefly touched before on, which is how do we actually trust the data, and how do we gather all the information we need from our open source dependencies. When we talk about this kind of information, we might incur in a couple of problems. One of them is that we might find too much data on the web about this. And another problem we might have is that the data we find has not always the same level of detail, or maybe it's not easy to consume from our automated ingestion in the pipeline. And it's also quite hard to find relationships between that data. So in order to address this problem, we want to mention one open source initiative that's built by, there are people who are from Google and other companies working on that, right? Like Kusari. Yeah, NCT. And they are, this is GUAC, which stands for Graph for Understanding Artifact Composition. This is kind of a novel technology. It's a kind of knowledge graph for managing supply chain metadata, which takes information from different sources, and we will see that in a moment. And you can actually query this database through a GraphQL API. I'm not a developer, but I'm sure many of you know GraphQL way better than me, but that's a way you can try to solve the problem of getting information from a trusted source, right? And this is a slide that comes from the official GUAC presentation. This is actually comes from Michael Lieberman from Kusari, which presented these slides to us as well in control plane, where we see the whole process of GUAC. You will find this picture actually also in the GitHub repo of GUAC, so I recommend checking that out. And you see that the way it works is by implementing ways of ingesting and normalizing data from public records, private records from organizations, which include SALS attestations, SBOMs, VEX documents, whatever, vulnerability scans results. And it will put all this information into a knowledge graph, tying together the artifact with all of this metadata. And as I said earlier, giving you the opportunity to query this data through a GraphQL API. Of course, this is still in very active development. I don't think not sure if it's even in beta at this stage, or they are actually working on it, like let's say in very active manner. But yeah, that's kind of an initiative which probably will have gained some traction in the following months, and might help us with managing all the data that we have to manage as part of our open source software ingestion. We move now to the second stage of the secure software factory, which is the build phase. And this is where we build, test, and package our artifact before storing it into a repository, like an OCI registry, as it was mentioned this morning. At this stage, we want to, of course, build our tool. This is when SBOM generation comes into place. So this means that we want to keep track of all the components that make our software package before, of course, pushing these to some form of repository alongside all the attestations and metadata that help us define how the software was built. As you can see from this slide, I want to point to one specific item here, which is on the left-hand side. That's where we talk about our attestation metadata storage. And as we mentioned here, of course, this is an OCI registry. We've seen this in the morning. So in an OCI registry, like, I don't know, ECR, AWS ECR, we can store images, we can store attestations as SBOMs alongside them, and that's very convenient. But we are also interested in to find a way where we can store information about our signatures so that there's transparency about them, and it's easier for them to be verified by a third party, right? And that's where the concept of transparency log comes into place. And yeah, a problem we have with supply chain data is that the community has to find a way to validate our attestations, especially if we are talking open source supply chains. And in order to do so, a transparency log is kind of required. And here we mention one specific tool for that. This comes as part of the Sigstore platform. It's called the Record, and it's a tamper-evident append-only log. This means that you can only add log lines to this log. You cannot modify existing log lines, and if you do so, there are cryptographic ways where you can actually validate that. So you can actually validate whether that was tampered with or not by a non-authenticated user. And yeah, this is kind of important for us as a technology, because that's a way where you can push your information, your metadata about your supply chains for others to validate that before deploying your application. And that's actually what we are going to talk right now. We are talking post-build phase. So at this stage, this is mostly a validation stage, a verification stage. Okay, at this stage, we are concerned with what we are actually deploying in our clusters. So in talking about Kubernetes components, this is an admission controller stage, let's say, where we actually validate signatures from our artifacts, where we actually verify the provenance from them, and that's where we are interested in getting information from a transparency log, for example. And that's also where, especially in high assurance environments, we might be interested in having some form of risk analysis, vulnerability analysis, just to cover the gap between when the pre-build phase happened and the post-build phase happens, right? So we want to be sure that that SBOM may be still relevant, or we might want to have some other forms of verification for our artifacts before we actually deploy that into production. Yeah, you see this final stage at the lower level in this slide. The green box, more or less green box, is the validate stage, and yeah, that's up to an admission controller to implement before we actually deploy our application. Something that I missed before, I want to mention that because it's not maybe so clear in the picture, is that both for our build runners and for our deploy infrastructure, we are also interested in having some form of workload and node attestation. That's also part of the secure software factory. because we want to be sure about the nodes. We want to validate those nodes as well as the individual tasks that are deployed, that are implemented by our pipeline. And that's where we might have to look for solutions for attestation, and we'll see that, yeah, CNCF has something about that as well. Yeah, we are getting to the end of the presentation. There is one link missing here. So we've talked about principles. Of course, we talked about threat modeling before, principles and controls, but how can we actually implement that in practice into a Kubernetes cluster? And of course, there's no a single way for doing that, but we want to mention here one specific sample implementation, reference implementation for everything we talked about here with the Secure Software Factory. And this is another open source project, which is called Fresca, which stands for Factory for Repeatable Secure Creation of Artifacts. This is another joint initiative where a set of open source tooling, CNCF tooling, is let's say, put together in the idea of everything, let's say, of building a secure pipeline where everything is deployed and is managed as code, both for the policy, the infrastructure, assurance, and of course, our pipelines. Here you see just a bunch of logos from technologies that are part of this ecosystem, but I want to mention that a little bit more in detail with the final slide from this presentation, which is a sample pipeline that it's actually part of the Fresca sample pipelines. So you can find this information in the Fresca repository as well. And this is showing how you can actually implement all of everything basically we've talked about into a single Kubernetes cluster in the context, in this case, of a build pipeline. So here we are not really talking about deployment, we are talking about building of our packages. And here we see our pipeline belongs to the Tekton pipelines namespace within our Kubernetes cluster. Tekton pipelines is a CNCF project for building CI/CD pipeline. And yeah, that's observed through a Tekton chains controller that you see on the right. This is a controller that you put on top of a Tekton pipelines instance. This monitors the pipeline runs that are executed in your clusters and helps with building provenance information and attesting this information before pushing it to an OCI registry like ECR in this case, and of course to a transparency log like record using the in-toto attestation format. Of course, in order to sign this information, you need keys, and as part of Fresca, they propose Vault as a solution for doing that. And we also have Spire, which I'm sure some of you might be familiar about. That's another CNCF project, a graduated CNCF project, which implements the SPIFFE identity framework, and it's also very relevant in this use case because through Spire and SPIFFE, of course, you can generate X509 certificates. They are called SVs in the context of SPIFFE and Spire. And through that, you can cryptographically attest workloads running in your pipelines, so you know that you're running what you're expected to run, as well as the nodes that belong to your CI runners. And yeah, we have also finally Kyverno in this picture. That's not really. We might have had like Open Policy Agent that is the admission controller part that I was talking about earlier. So that's taking care of enforcing your organization policies on the code that you're running in your pipeline. So if you're running from a trusted registry or something like that. So to conclude, problem space is very large. Francesco has shown that before. And one way you can tackle this very large problem space is by threat modeling it. And when you threat model, you want to, let's say, reduce the scope as much as possible, so decouple the big problem into smaller problems. The good part about this is that open source and community have a lot of initiatives in this place, and I've talked about CNCF and OpenSSF a lot here, and so you can try to get this information and try to retrofit your existing pipelines, especially if they are Kubernetes-based, because as you see, there are many Kubernetes-based solutions for dealing with this. Yeah, as a final remark, of course, you are not alone, so you can join all of these communities, and that's the cool part about it, and of course, you can contribute. So, thank you very much.
Vai, se vuoi.
No, yeah, we are taking questions. That's it. What's the QR code for?
Per il libro.
Ah, that's for the book. Okay.
Ok, un applauso un po' più caloroso.
Sommersi di informazioni.
Sicuramente li avete sommersi di informazioni, poi era un contenuto anche abbastanza denso, proprio. Ci sono domande, dubbi, perplessità? Abbiamo proprio un minuto. Perfetto, ok. Io niente, vi ringrazio per il vostro tempo e complimenti anche per l'intervento tosto. No, tosto come argomenti perché...
Buffer overflow.
No, buffer overflow no, però tosto, molto tosto.
Thank you.
Grazie mille.
Sì, chiaramente siamo qui, quindi parliamo anche offline.
Thank you.